So another exciting video on looking at relationships of regular polygons that are inscribed within circles. All right, so again, when I'm talking about being inscribed, we are talking about the vertices. So in this case, there happens to be 4. It's a square, are on the circle. So here's a square. Again, the apothem is a length that's going from the center to one of the sides. This is the radius. There could be another radius over here, and we could break this up into 4 triangles and find the area that way. Here's a 3-sided. Okay, so here's a 3-sided. Again, the vertices are on the circle. This is the apothem. It's coming down. It doesn't have it here, but that is going to be perpendicular. Okay, and that apothem, if I were to go ahead and draw this other radius, it's going to be the height of one of those triangles. And you can see as I just start to change, there's the square again. Here's a 5-sided. Here's a 6-sided, a hexagon. I could definitely see some things that are happening, correct? This is still staying a 90-degree angle, but this angle is definitely getting smaller. And if I continue to do that, now there's a 7, here's an 8, here's a 9. All of a sudden I jump to a 30, right? I can see that that angle right here is getting really small, okay? But the apothem, right, is still going to be perpendicular to one of those sides. And you'll notice, as I mentioned last week, right, here's a 30-sided. It practically looks like a circle, right? And if I continued, now I'm at, right now this is 150-sided, and it looks pretty much like a circle, all right? So again, I'm going to go in slow motion, kind of back to different sides. That's a 7, that's a 6, that's a 5, that's a 4, and I'm back to a 3, okay? All right. Now, what else am I going to show here? I'm going to talk about how do I find. So for example, if I were to, just to answer a few questions that you might be seeing in regards to area of regular polygons, right here you can see I have a regular triangle, an equilateral triangle inscribed again in that circle. And let's say I had a problem that asked me to find, right, maybe I'm given that the central angle is 72 degrees. So I'm given that there's a central angle. So again, a central angle would be if I started at the center of this polygon. Okay, from right here, that would be considered a central angle. So how many central angles are there in this triangle? There's going to be 1, 2, 3. How would I find that? I would need to do 360 because again, all the way around is going to be 360 degrees. I'd have to divide that by 3. So if I were to do that, that would be a 120-degree angle. So each of these would be 120 each. Okay. Now, what if though I was given a problem that said the central angle, I'm not given a picture, okay, so maybe I don't have, I don't have any of this here, okay, and all I'm given is that the central angle is 72 degrees. That's it. Let me go back and put some spaces in between here. So I'm only given that the central angle is, it's not letting me do a space there, but all I'm given is that the central angle is equal to 72 degrees. How could I find the number of sides? Well, using the reasoning I just mentioned, I know that it was 360 divided by the number of sides gave me the angle measure. So I then know that I must be able to do 360. So I must be able to do 360 divided by 72, and that's going to give me 360 divided by 72, that's 5, right? So that's going to give me a 5-sided, right? Because I know that there's that relationship with division. 360 divided by 5 would be 72, and I know that 5 times 72 is 360. So if they gave me the central angle, I just need to divide 360 by that and it will give me the number of sides. Now, what if I had another type of problem? What if I had a problem that it asked me to find, again, I'm not given any type of picture, okay, and I'm just given that I want to find, I need to find, let's say, the apothem, all right? So I need to find the apothem, and I'm told that it is a square. I'm told that it's a square and it has a side length of 12. So what I would do then is I would go ahead and draw myself a square. Okay, so there's a square, and it tells me that it has a side length of 10. So that means that this length is 10, right? This length is 10. But I want to find the apothem. So if I'm going to find the apothem, I'm going to need to first go ahead and kind of break this up. I know that that would be considered the radius. I think I'm going to go back. I kind of don't like the way that's looking. I'm going to go back and do that just a little bit nicer. So I know that this would be a radius, and I know that this would be a radius, and I know that there would be 4 of those. Because again, I know I don't have it here, but I have to kind of visualize, right, that that circle is going around that shape. The apothem is going to come down, straight down, and that's what I'm trying to find. So I'm trying to find this length right here, which is the apothem, which I'm going to call A. So it's going to come down, that apothem comes down, it's going to divide this into 2 equal parts, so this now becomes 5. This becomes 5. And hopefully by now you already know that this central angle, since there's 4 of them, 1, 2, 3, and 4, 360 divided by 4 is 90 degrees. So this is 90, 90, 90. The apothem cuts it into 2 equal pieces, okay, which makes this right here 45. And it makes over here also 45. So it looks like I have a 45, 45. Again, this is 90 degrees, okay? So that's 45, 45. And there's my special right triangle. That means that these 2 legs must be the same length. The radius must be 5 times square root 2, which they didn't ask me, but that could be another question that could be answered. So that means the apothem has to equal 5. And that would be my answer. All right, finding the apothem. All right, I hope that this video makes sense for you. If you have any questions, again, you know how to get in touch with me.